Hi, it's Dave Giles here for the next lesson of Cambridge International IGCSE Physics, Unit P1, Forces, Motion and Energy, and today we're looking at terminal velocity. And by the end of this lesson, I want you to describe terminal velocity and factors which affect it. And we'll do a quick recap to start us off with velocity time graphs here. So describe the acceleration for each of these. So the key word is the acceleration I want you to describe. So this one here, the first one, velocity is continually increasing, so that means accelerating, constant, because it's a straight line, or sorry, diagonal line rather, but it is straight. Here, velocity is constant, so that's zero acceleration. Same here. Now here, you can see the gradient is constantly getting steeper and steeper, which means it's acceleration, it's accelerating, and the acceleration is continually increasing. And lastly, this one here, it is accelerating, but it's continually decreasing. Now, a lot of people say this is decelerating, but it's not. The velocity is constantly getting bigger. Maybe it's leveled off right at the end here, but it's continually getting bigger, the velocity. However, the rate at which the velocity is getting bigger is decreasing over time. So a car of mass 500 kilograms has an engine which produces 8,000 newtons of thrust. What's the acceleration of the car? So this is just a quick recap of previous learning again, because this will be linked into today's lesson. So acceleration is force over mass. This is from Newton's second law, F equals ma. Acceleration is F over m, 8,000 over 500, 16 meters per second squared. Now, why in reality would the acceleration be much lower? Why are you not going to get a constant 16 meters per second squared acceleration? Well, give you a few seconds to think about it. The reason is the air resistance and friction as well from the road will produce an opposing force. Okay, so there's an opposing force apart from the engine thrust. So let's look at factors which affect air resistance. So the first one is surface area in contact with the air. So these are two pieces of clay, both the same mass, etc., both attached to a parachute, but parachute A is larger than parachute B. So therefore, air resistance of A is larger than parachute B. So therefore, it'll have a high, with the bigger opposing force, A will have a lower rate of acceleration than B, and it will reach terminal velocity as it'll have a lower terminal velocity, but we're going to look at terminal what that is in a few moments. And the other thing affecting air resistance is the speed of an object. As a car moves faster, the air resistance on it increases because there's more particles hitting it every single second. So therefore, there's going to be more air resistance. And similarly, the reason the air resistance is bigger here is because you've got a wider surface area, so it can actually physically catch more air. Whereas here, more air is hitting it every second because it's traveling faster every second once it's increased its speed. So let's have a look at what is meant by terminal velocity. So is velocity reached when the force on an accelerating object balance and it stops accelerating. So let's take a look. Skydiver here. So we'll start off on Earth. So the moment the skydiver jumps out of the plane, for a fraction of a second, he is accelerating due to gravity or due to his weight caused by gravity. So his acceleration will be 9.81 meters per second squared. And the downward force won't change. This should be constant. However, the second he starts to move, air is hitting him, which produces an opposing force. And as we said earlier, as he speeds up, as he gets faster, as he's accelerating, there's more air hitting him every second. So the opposing force will actually get bigger with time until eventually you get terminal velocity when the air resistance is equal to the weight of the man. So let's say he's 1,000 newtons. That means the air resistance, once he reaches terminal velocity, is also 1,000 newtons, and he's traveling at whatever his terminal velocity is. Now, he's a skydiver. If he doesn't open his parachute, he's not going to have a very nice outcome. So what he'll do is he will open his parachute, which will massively increase his surface area. So what happens then is he will then start to decelerate because now the upward force will be greater than the weight of the object of the man. So he will start to decelerate. But as he slows down, there's less air hitting him every second. So actually his rate of deceleration will decrease until eventually, again, he reaches the second terminal velocity where weight equals the new air resistance, also rather the air resistance now equals his weight again, and he's got a new terminal velocity which is hopefully much lower than his original one. It'll still be pretty fast, and he's still at risk if he doesn't land properly, breaking legs, etc., but certainly a lot safer than without a parachute. Next up, we'll have a look at what happens if he was to do it on the moon. Well, on the moon, it's a little bit simpler. There's no air. So the acceleration is less on the moon. So acceleration due to gravity on the moon is about 1.6 meters per second squared, or we'll say roughly 1/6 of the value of it on Earth. So that means that it is constant, his acceleration, a little bit less than Earth at first, but it won't stop. So velocity will keep on increasing, and even if he opens his parachute, there's no air, it's not going to make a difference. When he eventually hits the floor, or hits the surface of the moon, he unfortunately passes away. So let's have a look at that graph once more. So just a quick summary of what I said earlier. Initially, a skydiver accelerates due to weight caused by gravity, 9.8 meters per second squared. Here, air resistance creates an upward force. I said here, it's basically the second he jumps out, as soon as he starts moving, reducing the resultant downward force on the skydiver, so the acceleration decreases. As air resistance equals weight, the skydiver has reached terminal velocity, opens his parachute, area increases, so air resistance increases, causing the parachute to decelerate. As he slows down, the size of the air resistance decreases until again air resistance equals weight, so the skydiver has reached a new terminal velocity. And it's the same in a fluid, or sorry, a liquid rather. Now, the thicker the liquid, the higher the upward force it will be. So if you drop a ball bearing through a fluid here, so instead of talking about air resistance, the only difference is you'll have a frictional force called drag caused by the liquid the object is falling through. Okay. I think that's better to mention. So I'll give you a very quick question now on terminal velocity through a liquid first. So the diagram shows a steel ball bearing falling through a tube of oil. The forces L and M act on the ball bearing. What causes force L? Now, force L is weight. However, what causes it is gravity, or the product of mass and gravity. The distance time graph represents the motion of the ball bearing as it falls through the oil. Explain in terms of forces L and M why the ball bearing accelerated first but then falls at a constant speed. So initially force L is greater than force M. As the speed increases, force M increases. When M equals L, speed is constant, so the resultant force is 0. Okay. So now we'll have a look at some paper 2 multiple choice questions based around terminal velocity. Okay, I'll let you pause it, have a go at them, and then we'll talk through them in a second. Okay, an object. So by the way, you can see it's quite a recent paper from October, November 23, this question. paper 2-1, because there's 3 versions of it, of the same paper every exam series apart from March. So an object reaches terminal velocity after being dropped and falling through air, which graph shows how its speed varies with time. So there's no parachute in this example, it's just reached terminal velocity naturally. So the answer is C. The diagram shows speed time graph for a moving object. Which description of the object's motion is correct? So we've got 3 possibilities here. Pardon me. I'll start at the bottom. Constant speed. Well, we can see the speed's changing. It's definitely not that. Constant acceleration. Well, we can also see that the gradient is changing, so it's not that. Decreasing speed. Well, it looks like it's constantly increasing, so it's not that. Decreasing acceleration, yes. Because the gradient, it's accelerating constantly, but the gradient is getting less and less steep. So it's A. A light ball is held at rest at the top of a tall cliff. It is released and falls through the air, eventually reaches its terminal velocity. Which row describes the behavior of the ball as it descends? Okay, so the initial acceleration of the ball will be due to gravity. And then the final acceleration of the ball as it reaches terminal velocity is constant speed, so 0 acceleration. So the answer is therefore C. Which statement about a falling object accelerating close to Earth's surface is correct? So we've got a series of statements here. Let's go through them from the top. The weight of the object is increasing and the force of air resistance of the object is decreasing. Well, weight is usually constant, so it can't be that. And air resistance would normally increase as well, so 2 reasons, not that. The weight of the object and the force of the air resistance of the object are equal in magnitude, but act in opposite directions. They do act in opposite directions, but not equal in magnitude. Air resistance is changing. The weight of the object is constant, but the force of air resistance on the object is increasing. Yes, that is true. We'll just double check D. The weight of the object is less than the force of air resistance. That's not true. So it's C. And the final one, a parachute is falling at terminal velocity without her parachute open. She now opens her parachute. What is the direction of her motion and what is the direction of her acceleration immediately after she opens her parachute? So the direction of motion of the parachutist is obviously she's moving downwards, and the acceleration, well, she's after opening the parachute, she's decelerating down or accelerating upwards. So the answer is B. Okay. Thank you very much, everyone. The next lesson will be on on circular motion. I'll be uploading that soon. Thank you and see you then.